Hello everyone. In the previous lectures, you have learned about normal and standard flow in C programming. You have also learned about selection flow, like for example, if or if-else statement and nested version of that. And today we are going to deal with the extended version of this selection flow, which is called a loop. So why we need a loop? For example, assume that I want to get data from thousands of students, and in order to do that, if I want to define it as a standard flow, then in that case I should type 1,000 number of scanf and printf. So it's too much. And why we need C programming or any other programming languages? Because computers can do things which are not feasible for us. So that's why we can define it as a loop so that we can ask information from the user 1,000 times by just typing scanf or printf, for example, only once. So this is how it works. Look here, for example, we have while. This is a kind of loop that we will introduce to you today. And in the next lecture, we will talk about for loop and do while. Okay, how this is working. Take a look at this one, while, and inside it, we have this expression. So it's very similar to if, but the only thing is that whenever the condition holds, this statement will be executed again and again until the condition doesn't hold. So if, for example, the variable that you define here will be as a constant here as a statement, then you will deal with an infinite loop. But usually we are not interested in infinite loops. We want at a certain point that finally we get out of the loop so that we can give the user the output and so on. So the difference between while and if is that this statement doesn't won't be executed several times, just one time. But for while, it will be executed again and again until this condition doesn't hold. So let's see what's happening here. First, we assign the value 2 to product as an integer, and we check whether product is less than or equal 1,000 or not. Yes, 2 is less than 1,000, so this condition holds. And we execute this part. So product is equal to 2 times product. Now the value of product is 4. So we check whether 4 is less than 1,000 or not. So you see the value for product is increasing. And at a certain point, finally, we get a value which is more than 1,000. And that's the time we finally get out of the loop. So this is the flowchart of what I just talked about. And you can see the format, which is very similar to if. Inside while we have the expression and the statement one that we are running in our program. So how it works again. First we check like if the condition holds here. If this is the case, then we will apply the statement, and again we return to the expression and check it whether the condition holds or not. If it doesn't, then that's the time we get out of the loop. For if statement, we just check the expression and we go to the statement only once if the condition holds. If it doesn't hold, we will jump over it anyway. So let's take a look at this example. Here we can see inside the main function, we define count as equal to 1. While count is less than or equal 10, do these things. So you see not only one statement, we have 2 statements, and we should make sure that we put them inside the block. And it's important what things that you are insert inside the block and which things you are typing outside this block. So the things that usually we want to repeat, These are the statements that you should be careful to insert it inside the block. So here, the first thing we do is printing out the result of count. So count is equal to 1, then we print it out, and we add 1 to it. You remember this notation? Whenever we have plus plus, it means that count is equal to count plus 1. So count is now is equal to 2. So again, we check if 2 is less than or equal 10 or not. This is. So we will print 2 and we add 1 to it. So finally, at which point shall we stop? At 11. So when count is equal to 11 here, we check this expression, whether this inequality holds or not. 11 is not less than or equal 10, so we get out of this loop and we reach this system pause. That's why you see press any key to continue on the sample run. So the result will be 1, 2, 3 until 10. 11 won't be printed out. Why is that? Because here we have printf before count plus plus. If it was, for example, before it, we may see other numbers that you don't see here. So these things we should be careful about. The order matters that you apply, you type these things inside your loop. All right, the second example is related to infinite loop. You see here we don't add anything to count. Count is always equal to 1. So this condition holds forever. That's why we have an infinite loop. Usually in our programs, we are avoiding it because we don't want our C program to run forever. We want it to stop at a certain point. Sometimes we know exactly how many data we are going to get from the user. For example, I told you that we want to get information from thousands of students. So I already know that there are thousands of students. Or if, for example, in your class we have 100 students, then I know exactly I should ask the user 100 times to give me the information about, for example, age of students or grade of students and so on. And that's what we call counter control repetition. So an example related to that. So assume that I already know that number of students are 10. So the number of students is 10, and I want to calculate the average of these students. So we get the grade from the students one by one. We reserve it inside the summation. And then at the end, I want to calculate the average of their grades. So this is how we should type the program. Let's tackle it from the beginning. So first, I define count as an integer, which is equal to 1. You may ask me why this is equal to 1. In while loop, we define the upper limit to be equal to 10. So if this is an integer and it starts with 1, so we will have 1, 2, 3, and we count until 10. So 10 number of students. If I define count as 0, this is no problem. But the thing is that for the expression of while, I should make this one equal to 9. Or, for example, erase the equality sign here, so it will be less than 10, not less than or equal to 10. The goal is that 10 times this loop should be executed. That's why it's really up to you what you prefer, but usually it's easier to start with 1 and use less than or equal to the upper limit. So we already know that there are 10 number of students, so here this is the way we defined 1 to 10. And don't forget to put count plus plus, so we want to increase the number of count until it reaches 11, and finally we get out of the loop. So from the beginning, we ask the user to enter the grade, and we save it inside the grade variable. You see, for all of them, we should define it beforehand. So we define grade as integer. And as I usually suggest you guys to use float instead of integer if we don't specifically ask you to do integer, because it makes your job much easier. All right, so total, we define it as 0 because at the beginning it should has a value, so that when you add the grade to it, it will be, for example, 98 plus 0, then the first total would be 98. And it will run again and again until 10 times, and we gather all the grades and we add them to each other. So at the end, we will have the summation of all of the grades. But at the end, we need to find the average of them. So summation of the grades divided by 10. I already know what's the value of number of students, you see? So I define it here. And that's why we should be careful that the block that you defined here for the loop, we don't insert average inside it, because we want to calculate average only once. So the things that we want to do again and again, they are happening inside the loop. And the one that you want to calculate only once, you see, I put it outside the loop. And at the end, you can print out the result. So this is a sample run. You get these grades from the user, and at the end, the program will give you the output 81. Why it doesn't have decimal point? Because we define everything as integer. If you want decimal point, then this is important that we define it as float number, as we usually suggest. So not always we know exactly how many, for example, students we are dealing with, how many data we want for our database. Sometimes it depends on the user to decide it, and sometimes it depends on how many data we have in hand. So because of that, we need to define another format for our loop. This is again while loop, but we need another way to compensate this problem, because now I don't know, we have 10 number of students, 100 number of students, or any other information that I need to enter in my database or not. So we define a thing named Sentinel value. We can call it signal value, dummy value, or flag value as well. And let's see in an example what we mean by that. So here I want to enter a grade, and I don't know exactly how many of grades we have, how many students we have. The user is going to enter the grade. How many? We don't know. So count is equal to 0 from the beginning. Grade and total, we define it as 0. Now this time we define average as float. You can even define grade and total as a float. You see in the program, they convert by using this formula. In order to avoid it, you can from the beginning use float here, so that we don't need to apply such conversion. All right. So we ask the user to enter a grade, and we get that grade from the user. We save it inside the grade variable. Please pay attention here. Printf and scanf happened before the while loop. In the previous example, we didn't need to do that. Everything was happening inside the loop when we talked about printf and scanf. Why we do that? Because we want to check whether the user enters Sentinel value or not, the flag value or not. And the user knows already what's the flag value, because the programmer already defined it. The flag value we define -1, because we are sure that the grade is between 0 and 100. We don't have -1. So we tell the user, whenever you don't have any data to enter the program, just type -1. How can we inform user about such things? Maybe we can use a printf before starting the program, or even before the first printf here, when we want to get the information from the user, that whenever you want to stop the program, just type -1 so that we get out of the loop. All right, so that's the reason. First, we ask the user here outside the loop that please give us the first grade. Then if this one is not equal to -1, which is our flag value, then we are going to run this block. So first thing we do is that we just calculate the summation. We accumulate all the grades one by one. We use this count because we want to actually go through all of them one by one. But here, please be careful if you compare it to the previous one. Here we don't use count inside the while condition. We use the Sentinel value related to grade. And count here, the main goal for that is to find the total number of students, not just go through them one by one. Because you see here, we don't use count. If we use it here, it was the reason. But now that I look, no, this is the reason for calculating the total number of students, because we don't know it from the beginning. So this is nothing to do with the condition here. The condition is related to the grade, whether this is -1 or just the normal grade that the user is entering. So again, you can see printf and scanf happen to be inside this loop. So one time I define it before the checking of while loop, and one time I define them inside the loop. And later you will see when we define for loop, you don't even need a flag value there. But this is the beauty of while loop, because we can define Sentinel values easily. So after checking all of the numbers, after entering all of the grades by the user, as soon as the user enters -1, we get out of this loop and we check here. If user enters any number, because if from the beginning user types -1, we should check that, because the formula contains a division. And if the count is equal to 0, this division is not defined as a real number. And in float, we don't define it. For complex numbers, we need another type of data. Okay, so if there isn't data, then we will calculate the average. But if it's not, then we say no grades were entered. So this is a sample run. You can see here the user enters this much of data, and we understand 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 number of students here. Oh, sorry, 8 number, because this is the flag value. So 8 number of students. So that's how we understood it by calculating count here. You see, for example, this one, we checked it, count was equal to 0. Now this is 1. Again, we go through the loop, then count is equal to 2. And at the end, we calculated to be 8. So inside our formula, which is outside the block, you see, while is here, the block related to the while loop is here, average is outside of. This block is related to the if condition that you can see here. All right, another example. This example is very interesting because we have 2 calendars here. We want to check the test results. Either the student pass or fail the course. For passing, we are assigned 1. For failing, 2. Obviously, later when you learn about strings, you can even define them as pass and fail. But now we are dealing with integer and float mostly. So let's say passing is 1, failing is 2. Now we have 10 students. So exactly we know how many students we have. Now, the program must process 10 test results. Yeah, we already know about the number of tests. 2 counters can be used. One of them for the number of passing, the other one for failing. So the test result would be either 1 or 2, pass or fail. Now let's see how we can type such a program. You see here void instead of empty parentheses. They have the same meaning. We will cover it when we talk about functions later. So don't pay attention to it. You can just leave it empty like we did before. So first we define the variable passes equal to 0, failures equal to 0. These are the number of passing and number of failures. So we define student as 1. Here also we describe them. We mean by that student counter. You see these notations, C doesn't care about it. It's just a description so that we understand what's going on here. Sometimes you can even use it in your assignment as well to explain me, for example, this is what I meant by that. But usually for basic examples, it's not even necessary. So for result, again, we define it as integer. Now let's see what we are going to do. So we define a while loop, student less than or equal 10, and the first value, initial value of student was equal to 1. It means that most probably we want to add it one by one, 1, 2, 3, and count it until 10. Okay. So printf and scanf, you see, because I already know the number of students, you didn't need to use printf and scanf once before the loop. You used it inside the loop from the beginning. So you get the information from the user whether the student passed or failed the course. And you reserve it as an integer. So the user should enter 1 or 2 only. If result is 1, you see this is the way you checked it. Result double equality sign. So we should be careful, not just equality sign. Double equality sign because we want to check whether result is equal to 1 or not. So if this is 1, then add 1 to the number of passes because initially it is 0. We don't know how many students passed the course. So we decided by getting the information from the user. If this is 1, then add 2 passes. If this is failure, then add 1 to the failure. So the way they define it was using if else. So you see, for else, we don't need to put anything in front of it as a condition. You see, this is a condition for that. We have the expression inside it. Here, right away, we say about the statements as a block. In front of it, we don't have any expression. So I could even put the block in the next line so that there won't be any confusion about that. And obviously, there are other ways to define the number of passes, number of failures. And this is the beauty also of C programming, that not necessarily all programmers write the same codes for solving the same problem. And even we have similarity for the way that you type your codes, because when the program gets more complicated, for sure, your program won't be similar to your classmate. And by the way, look at here, student is equal to student plus 1, or you could type it student plus plus. And this is happening inside the while loop, because we want to add 1 to the number of students. So at the end, when it gets 11, we get out of the loop because we want to only enter numbers for only 10 students. So the block for while starts here and ends here. We should be careful about when we are starting a block and when we are ending it, because when the program contains lots of blocks, it can get confusing. You see, for example, this block is related to if. This block is related to else. So these things we should practice from not to be confused about. Many errors we can receive is just because we forgot about the order of the block. We think that, for example, the block ends here, but C program doesn't understand it because maybe you used another extra curly bracket here by mistake, and everything will change. So when you calculate the number of passes, then you print out the result. And also for the failure, the same story. And we want to print out if the number of passes is more than 8, then raise tuition. I don't know what's the cruel logic behind it, but this is the way they define the problem. Okay, so that was the goal, to count the number of passes and failures. We announce it and then check if this is more than 8 number of passes, then raise tuition. Otherwise, you don't need to print out anything. So a single if selection flow was good enough for us. And at the end, don't forget to always conclude your main function with return 0. As I said, obviously it's possible to solve this problem another way. For example, you didn't need to use else here. Just count the number of passes and number of failure, because you know about the total number of students. So the number of failure is 10 minus number of passes. And by using a formula before the printf statement here, you could easily solve it without using the else condition here. Okay, guys, so it was related to lecture 4. I hope you found it useful. From 10 minutes later, I will take your questions.